Okay, hi everyone, welcome back to this video series on the Comptia Security Plus course, Monitoring Methodologies. To operate a clean, secure network, you must keep an eye on your systems, applications, servers, network devices, power devices, and the entire network in general. One way to do this is to monitor the network. This surveillance of the network in of itself increases the security of your entire infrastructure. By periodically watching everything that occurs on the network, you will become more familiar with day-to-day happenings, and over time get quicker at analyzing whether an event is legitimate, seeing everything that happens on your network, and ultimately knowing everything that happens. This surveillance can be done in one of two ways: manual monitoring or automated monitoring. When manually monitoring the network, you are systemically viewing log files, policies, permissions, and so on, but this can also be automated. For example, there are several data mining programs available that can automatically sift through logs and other files for the exact information you want to know. In addition, applications such as antivirus, intrusion detection system IDSS, and intrusion prevention systems IPSS can automatically scan for errors, malicious attacks, and anomalies. The three main types of automated monitoring are signature-based, anomaly-based, and behavior-based. Signature-based monitoring. In a signature-based monitoring scenario, frames and packets of network traffic are analyzed for predetermined attack patterns. These attack patterns are known as signatures. The signatures are stored in a database that must be updated regularly to have any effect on the security of your network. Many attacks today have their own distinct signatures. However, only the specific attacks that matches the signature will be detected. Malicious activity with a slightly different signature might be missed. This makes signature-based monitoring vulnerable to false negatives when an IDS, IPS, or antivirus system fails to detect an actual attack or error. To protect against this, signature-based systems should be updated to bring the system up to date with the latest signatures. When it comes to intrusion-based detection systems, the most basic form is the signature-based IDS. However, some signature-based monitoring systems are a bit more advanced and use heuristic signatures. These signatures incorporate an algorithm that determines whether an alarm should be sounded when a specific threshold is met. This type of signature is CPU intensive and requires fine-tuning. For example, some signature based IDS solutions use these signatures to conform to particular networking environments. Anomaly-based monitoring. An anomaly-based monitoring system, also known as statistical anomaly-based, establishes a performance baseline based on a set of normal network traffic evaluations. These evaluations should be taken when the network and servers are under an average load during regular working hours. This monitoring method then compares current network traffic activity with the previously created baseline to detect whether it's within baseline parameters. If the sampled traffic is outside baseline parameters, an alarm will be triggered and sent to the administrator as long as the system was configured properly. This type of monitoring is dependent on the accuracy of the baseline. An inaccurate baseline increases the likelihood of obtaining false indicators, such as false positives. Normally, false positives are when the system reads a legitimate event, such as an attack or other error. This can happen with an improperly configured IDS or IPS solution. If too many false indicator alerts are received by the security administrator, then the IDS IPS should be reconfigured and baselines recollected, and or those type of false alarms should be disabled. Behaviour-Based Monitoring. A behaviour-based monitoring system looks at the previous behaviour of applications, executables, and or the operating system and compares that to current activity on the system. If an application later behaves improperly, the monitoring system will attempt to stop the behaviour. This has advantages compared to signature-based and anomaly-based monitoring in that it can, to a certain extent, help with future events without having to be updated. However, because there are so many types of applications and so many types of relationships between applications, this type of monitoring could set off a high amount of false positives. Behavior monitoring should be configured carefully to avoid the system triggering false alarms due to legitimate activity. Table 13.1 summarizes the monitoring methods discussed. Keep in mind that some systems, IDS, IPS, and so on, might combine more than one of these monitoring methods. Monitoring method description. Signature-based monitoring network traffic is analyzed for predetermined attack patterns. These attack patterns are known as signatures. Anomaly-based monitoring establishes a performance baseline on a set of normal network traffic evaluations, requires a baseline. Behavior-based monitoring looks at the previous behavior of applications, executables, and or the operating system and compares that to current activity on the system. If an application later behaves improperly, the monitoring system will attempt to stop the behavior. It requires a baseline. Using tools to monitor systems and networks. All of the methodologies in the world won't help you unless you know how to use some monitoring tools and how to create baselines. By using performance monitoring gizmos and software, incorporating protocol analyzers, and using other analytical utilities in the GUI and the command line, you can really watch the network and quickly mitigate threats as they present themselves. In this section, we use the performance tool in Windows, the Wireshark protocol analyzer, and other analytical tools within the command line in the GUI. These are just a couple of examples of performance and network monitoring tools out there, but they are commonly used in the field and should give you a decent idea of how to work within any tools in these categories. Performance baselining. We mentioned in chapter 4, OS hardening and virtualization, that baselining is a process of measuring changes in the network, hardware, software, applications, and so on. Documenting and accounting for changes in a baseline is known as baseline reporting. Baseline reporting enables a security administrator to identify the security posture of an application, system, or network. The security posture can be defined as the level of risk to which a system or other technology element is exposed. Security posture assessments, SPAs, use baseline reporting and other analysis to discover vulnerabilities and weakness in the system. Let's get into baselining a little more and show one of the software tools you can use to create a baseline. Creating a baseline consists of selecting something to measure and measuring it consistently for a period of time. For example, we might want to know what the average hourly data transfer is to and from a server's network interface. There are a lot of ways to measure this, but we could possibly use a performance monitoring tool or a protocol analyzer to find out how many packets cross through the server's network adapter. This could be run for 1 hour during business hours, of course, or every day for 2 weeks. Selecting different hours for each day would add more randomness to the final results. By averaging the results together, we get a baseline. Then we can compare future measurements of the server to the baseline. This will help us define what the standard load of our server is and the requirements our server needs on a consistent basis. It also helps when installing other like computers on the network. The term baselining is most often used to refer to monitoring network performance, but it actually can be used to describe just about any type of performance monitoring and benchmarking. The term standard load is often used when referring to servers. A configuration baseline defines what the standard load of the server is for any measured objects. When it comes to performance monitoring applications, objects are all of the components in the server, for example CPU, RAM, hard disk and so on. They are measured using counters. A typical counter would be the percent processor time of the CPU. This is used by the task manager. An example of one of these tools is the performance monitor tool in Windows. It can help to create baselines measuring network activity, CPU usage, memory, hard drive resources used and so on. It should also be used when monitoring changes to the baseline. Figure 13.1 shows an example of performance monitor in Windows. The program works basically the same in all versions of Windows, be it client or server, but the navigation to the programs will vary. To simplify matters, go to the run prompt and type performon.exe in Windows to open the program. The CPU is probably the most important component of the computer. In figure 13.1, the CPU counter hit 100% once, which is normal when opening applications and starting other processes. However, if the CPU maxes out often, then a percentage of the clients will not be able to obtain access to resources on the computer. If the computer is a server, then that means trouble. CPU spiking could be due to normal usage, or it could be due to malicious activity, or perhaps bad design. Further analysis would be necessary to determine the exact cause. If the system is a virtual machine, there is a higher probability of CPU spikes. Proper design of VMs is critical, and they must have a strong platform to run on if they are to serve clients properly, known as the counter. The CPU percent processor time is just one of many counters. A smart security auditor measures the activity of other objects such as the hard drive, paging file, memory, RAM, network adapter, and whatever else is specific to the organization's needs. Each object has several counters to select from. For example, if you are analyzing a web server, you would probably want to include the HTTP service request queries object, and specifically the arrival rate and current queue size counters in your examination. Now figure 13.1 shows the performance monitoring screen, but this only gives us a brief look at our system. The window of time is only a minute or so before the information refreshes. However, we can record this information over X periods of time and create reports from the recorded information. By comparing the performance monitor reports and logs, we ultimately create the baseline. The key is to measure the same way at the same time each day or each week. This provides accurate comparisons. However, keep in mind that performance recording can be a strain on resources. Verify that the computer in question can handle the test first before you initiate them. Making reports is all fine and good and necessary, but it is wise to also set up alerts. Alerts can be generated automatically by the system and sent to administrators or other important IT people. These alerts can be set off in a myriad of ways, all of your choosing. For example, if the CPU were to trip a certain threshold or run at 90% for more than a minute, although this is normal in some environments, or maybe the physical disk was peaking at 100 MBs for more than 5 minutes. If these types of things happen often, the system should be checked for malicious activity, illegal usage, or the need for an upgrade. A similar tool to performance monitor using Linux systems is called System Monitor. The different versions of Linux also have many third-party tools that can be used for performance monitoring. Mac OS X uses Activity Monitor. Protocol analyzers. We've mentioned protocol analyzers a couple of times already in this book, but we haven't really delved into them too much. There are many protocol analyzers available, some free, some not, and some that are part of an operating system. In this section we focus on Wireshark. Note that network adapters can work in one of two different modes. Promiscuous mode. The network adapter captures all packets that it has access to regardless of the destination of those packets. Non-promiscuous mode. The network adapter captures only the packets addressed to it specifically. Packet capturing programs have different default settings for these modes. Some programs and network adapters can be configured to work in different modes. Protocol analyzers can be useful in diagnosing where broadcast storms are coming from under LAN. A broadcast storm or extreme broadcast radiation is when there is an accumulation of broadcast and multi-packet traffic on the LAN coming from one or more network interfaces. These storms could be intentional or could happen due to a network application or operating system error. The protocol analyzer can specify exactly which network adapter is causing the storm. Protocol analyzers are also effective in finding header manipulation. Header manipulation can be accomplished by entering unvalidated data into the header of a packet and can ultimately enable XSS attacks, poisoning attacks, hijacking, and cookie manipulation. Header manipulation is common in HTTP response packets. The exploit can be prevented, corrected with proper input validation, and detected with a protocol analyzer. Protocol analyzers can look inside a packet that makes up a TCP/IP handshake. Information can be viewed includes the SYN, which is the synchronized sequence numbers, and the ACK, which is acknowledgement field significant. By using the protocol analyzer to analyze a TCP/IP handshake, you can uncover attacks such as TCP hijacking, but this is just one way to use a protocol analyzer to secure your network. Let's talk about industry standard protocol analyzer now. Wireshark. Wireshark is a free download that works on several platforms. It is meant to capture packets on the local computer that is installed on, but often this is enough to find out vulnerabilities and monitor the local system and remote systems such as servers. Because Wireshark works in promiscuous mode, it can delve into packets even if they weren't addressed to the computer it runs on. To discern more information about the remote systems, simply start sessions from the remote client computer to those remote systems and monitor the packet stream. If that is not enough, the program can be installed on servers as well. However, you should check company policy and get permission before ever installing any software on a server. Imagine that you were contacted to find out whether an organization's web server was transacting secure data utilizing TLS version 1.0, but the organization doesn't want anyone logging into the server. All too common. No problem. You could use Wireshark on a client computer, initiate a packet capture, make a connection to the web server's secure site, and verify that TLS 1.0 is being used by analyzing the packets as shown in figure 13.2. If you saw other protocols such as SSL 2.0 that should happen to raise a red flag, then you would want to investigate further, most likely culminating in a protocol upgrade or change. Always take screen captures and save your analysis as proof of work that you did, and as proof your conclusions and enduring recommendations. You can also save the packet capture file with the .pcap extension for further analysis. Remember that Wireshark can be used with a network adapter configured for promiscuous mode. It is set up by default to collect packets locally and from other sources. However, you can also capture and analyze packets using port mirroring on a network tap. Port mirroring, also known as SPN, is when you configure one or more ports on a switch and forward all packets to another port. The destination port is where your packet capturing is plugged in. Know that this can place a considerable load on the CPU of the switch, which can lead to dropped packets. A network tap is a physical device that intercepts traffic between 2 points of the network. It commonly has 3 ports, 2 of the 4 points to be monitored and a third for the packet capturing computer. This is a costlier solution but can monitor all packets and frames of information with no risk of dropped packets. How about another real world example? Let's just say you were contracted to monitor an FTP server. The organization is not sure whether FTP passwords are truly being encrypted before being sent across the network. By the way, some FTP programs with a default configuration do not encrypt the password. You could use a packet sniffer to initiate a capture of packets on the monitoring server, then start up an FTP session on the monitoring server and log into the FTP server. Afterward, stop the capture and view the FTP packets. Figure 13.3 shows an example of an FTP packet with a clear text password. Notice that frame 1328 shows the password LOCRIAN in the details. Clear text passwords being passed across the network is a definite risk. The vulnerabilities could be mitigated by increasing the level of security on the FTP server by using more secure programs. For example, if the FTP server were part of Windows, IIS domain-based or authentication could be implemented, or perhaps a different type of FTP server could be used, such as pure FTPD. A secure FTP client programs could be used as well, instead of using the command prompt or a browser to make FTP connections. The FileZilla or WSFTP programs could be used. So I'm going to leave it here today for this video. If you like listening, please consider sharing and subscribing. Thank you.